Your charger stays the same. The travel adapter holds the plug inside and connects to the foreign socket without a second thought. This everyday mechanism, wrapping an incompatible interface so it can communicate with an existing one, is the basis for a software design pattern called adapter. Once you understand the mechanics of this pattern, you'll recognize it throughout production-level codebases. The pattern is a bridge between two systems. It allows them to communicate without requiring you to tear down and redesign the original components. At its core, the object adapter pattern converts the interface of a class into another interface the client expects, specifically by using composition. This diagram shows the naive approach. When two separate systems need to talk, the common instinct is to write hard-coded, tightly tangled classes to force the integration. The trouble starts when requirements change. A new vendor or an updated API arrives, and you are forced to crack open existing code just to fit the new pieces in. Modifying working code to accommodate new integrations creates software fragility. It directly violates the open-closed principle, where code should be open for extension but closed for modification. Tightly coupled integrations eventually collapse. Dealing with legacy code requires a disciplined structural pattern to isolate the old from the new. Strip away the jargon, and the pattern relies on a single idea. Incompatible components become compatible via composition. This has-a relationship offers distinct advantages over inheritance. We start with the target interface. This is the stable abstraction your design leans on. On the opposite end is the adaptee. This is the incompatible legacy code or external library you cannot modify. To bridge them, we place the object adapter in the middle. It uses composition to hold a reference to the adaptee. Now we wire up the client. It strictly interacts with the target interface, with no visibility into the adaptee. There is also a class adapter variant. Instead of holding a reference, it uses an is-a relationship, relying on inheritance to merge the two classes together. Establishing this single abstraction seam between stable client code and volatile legacy systems is what gives the design its flexibility. Consider how the physical travel actors map to our software components: the unchanged charger, the adapter holding the plug, and the foreign socket. This mapping identifies exactly where the logic lives. The physical charger is your client code. It expects a standard connection and does not change. The travel adapter is the adapter class. It wraps the incompatible plug to perform the translation. And the foreign wall socket is the adaptee, the legacy system or third-party API providing power, but in a format the charger can't use directly. By isolating these roles, we can swap out the socket or the charger independently, as long as the adapter in the middle manages the translation. Let's build the composition-based object adapter. Watch how each layer strictly depends on the abstraction above it. In step 1, we define the target interface, payment processor. This is the contract the client will call. Step 2 introduces the adaptee. Our legacy payment system provides the necessary logic, but its method names do not match our new interface. In step 3, we create the payment adapter. It explicitly implements our payment processor interface to stand in for modern processors. Following composition, the adapter holds a private reference to the legacy system, passed in through the constructor. When the client calls pay, the adapter catches that call and delegates it, invoking the original legacy.makePayment method. Finally, step 4 shows the client instantiation. The client receives the adapter, which is already wrapping the legacy logic. Because the client strictly interacts with the interface, you can swap out legacy implementations without changing the calling code. Contrast that with the class adapter. It requires less boilerplate code because it doesn't need to store an object reference, but it binds the adapter to one specific concrete class. We use the same target interface and the same adaptee. Here, the payment adapter uses inheritance. It extends the legacy system while simultaneously implementing the modern interface. The pay method now directly invokes the inherited makePayment function. There's no delegation to a separate instance. The client instantiates the adapter directly, requiring no construction injection, since the legacy logic is built in through the class hierarchy. This comparison shows both structural approaches at once. While inheritance is concise, composition allows the adapter to wrap not just one class, but any of its subclasses. This offers a layer of flexibility that the class variant cannot match when working with complex hierarchies. No pattern is free. You must justify the added complexity of the adapter based on the specific needs of your system. The object adapter is powerful because it can adapt any subclass of the adaptee and maintains loose coupling through composition. However, it requires more boilerplate code and introduces a layer of indirection, making execution flow slightly more complex. The cost of this indirection is only worth it when the flexibility of decoupling provides a clear advantage in maintaining your legacy integrations. Use the adapter pattern when you need to manage multiple adaptees, or when language constraints like a lack of multiple inheritance make other approaches impossible. Do not confuse it with the decorator pattern. While they look similar, the decorator adds new behavior to an object, whereas the adapter's only job is to change the interface. In an interview, articulating this difference between changing an interface and adding behavior demonstrates a clear understanding of architectural intent over implementation. This is the pattern in one breath, making incompatible interfaces work using a has-a relationship. Look for this pattern in the libraries you use every day. If the analogy made it click, drop your example in the comments and subscribe for more of the architectural catalog. Mastering the adapter pattern turns the complexity of legacy integration into a controlled, disciplined procedure.